Hello again, it's Mrs. Tremblay. In your previous lesson, you looked at fractions that had the same numerator when comparing and fractions that had the same denominator when comparing. And you're still going to want to ask yourself, hey, are the numerators the same or are the denominators the same when you're comparing? And you can use those strategies we talked about before. There are two other scenarios that you might run into when comparing fractions, and I want to go through those today with you. So, the first scenario we're going to look at is comparing fractions where one denominator is a factor of the other. And you have to remember that factors are numbers that you multiply together to get a product. So in order to compare fractions where one denominator is a factor of the other, you can create a comparison of the fractions with the same denominator by multiplying one of the fractions. So you might be thinking, what are you talking about, Mrs. Tremblay? It's been a while since we have done this. So here I have 5/8 and I have 19/24. And if you're thinking about the previous lesson, you might be asking yourself, are the numerators the same? And the answer is no. Then you can ask yourself, okay, well, are the denominators the same? And the answer is no. So in order to compare those, it's kind of tricky because the denominators are not the same. So comparing 5/8 and 19/24, you might think, well, we could draw a picture of that. And we could draw two rectangles of the same size. We could cut one of those up into 8 pieces in shade 5, and we could cut one up into 24 in shade 19, and see which one takes up more space. But we'd have to be very detailed and make sure that our pieces were the same size, and it would just take a lot more time than the strategy I'm going to share with you. So that strategy is a fine strategy, but this one will take a little bit less time. We saw in our previous lesson that when you compare fractions with the same denominator, the greater numerator is greater because you'd have more pieces of the same size. So what we're going to do is we're going to make these two fractions have pieces that are the same size. So how are we going to do that? We learned previously that we can create equivalent fractions, fractions that are worth the same amount, by multiplying the numerator and denominator by the same digit, because it's kind of the same thing as multiplying by 1, and multiplying by 1 does not change the value, right? That multiplicative identity, do you remember that? We had a lot of fun with that word. So when I say one denominator is a factor of the other, here's what I mean. When I look at 8, I can multiply 8 by something to get 24. What can I multiply 8 by to get 24? If you said 3, winner, winner, chicken dinner. So if I know that I can multiply 8 by 3 to get 24, and I want to create an equivalent fraction, then I'm going to multiply my numerator by that same digit. And 5 times 3 is 15. So when I multiplied 5/8 by 3/3, I have some different digits here. I now have a different fraction, 15 over 24, but it's equivalent to 5/8. Because when you multiply by 3 over 3, we learned that if you have 3 out of 3 pieces, you have a whole. And multiplying something by 1 does not change its value. So we didn't change the value of 5/8. We just changed what it looks like. So now it's super easy to compare. 15/24 and 19/24, those pieces are the same size. So 19 pieces is going to be greater. So you've learned to ask yourself, are my numerators the same? You've learned to ask yourself, are my denominators the same? Now, when the answer to those two questions is no, you need to learn to ask yourself, can I multiply the lower denominator by a number to get the higher denominator? And if the answer is yes, then you'll create an equivalent fraction to compare. So here are your examples. And again, you can go ahead and pause it. You can try to solve these on your own, or maybe you want to watch one with me as an example and then try the rest on your own. Or maybe you don't want to try any on your own and you just want to watch and listen and learn. That is fine. So my numerators are not the same. My denominators, not the same. I look at my lower denominator. I can multiply 6 by something to get 12. I can multiply 6 by 2, and that will give me 12. Now, in order to make an equivalent fraction, I need to multiply my numerator by the same thing. So 5 times 2, that's 10. So when I multiplied 5/6 by 2 over 2, that's the same as multiplying 5/6 by 1. I'm now comparing 3/12 with 10/12. And 10/12 is greater. That would mean 5/6 is greater than 3/12. Maybe some of you are thinking, well, Mrs. Tremblay, I know that 6/12 is half, and 3/12 would be less than half. And I know that 3/6 is half, and this is more than half, so I already knew 5/6 was greater by using that strategy. That's fantastic. That works just fine as well. All right, 3/4 and 7/8. Not the same numerator, not the same denominator. I can multiply 4 by 2 to get 8. And I can multiply 3 by 2, so I have an equivalent fraction. So what I'm really comparing here is 6/8 with 7/8. Same denominator, greater number of pieces wins. I do not have the same numerator. I do not have the same denominator. I can multiply my lower denominator by something to get the higher one, though. 6 times 2 equals 12. So to make an equivalent fraction, I need to multiply my numerator by the same exact thing. Are you noticing it's the same as this one? Isn't that nice when that happens? 5 times 2 is 10. So I'm really comparing 11/12 with 10/12 because those are equivalent. So if I have 11 pieces that are the same size as these, that's greater. All right, last one here. Not the same numerator, not the same denominator. My lower denominator is 7. I can multiply 7 by something to get 21. 7 times 3 is 21. So I'm going to multiply 5 by the same value, and 5 times 3 is 15. So these are equivalent because I multiplied 5/7 by something equal to 1. And multiplying by 1 doesn't change it. 15 out of 21 is going to be more than 13 out of 21 because those pieces are the same size. All right, the final way to compare. Sometimes you're going to look at some fractions and you're going to be expected to compare them, and you're going to ask yourself those 3 questions we learned, and none of them are going to work. 4 and 5, not the same. 7 and 8, not the same. Is there a number I can multiply 7 by to get 8? Nope. So what are we supposed to do? Well, I'm here to tell you. All you have to do is multiply each fraction by the opposite fraction's denominator over itself to create common denominators. And those are a lot of fancy words, right? So let's put it into action. I feel like that helps. So we asked ourselves those 3 questions. None of them are true. So the directions say I can multiply this fraction by the opposite denominator over itself. So that would mean I would take 4/7 times 8 over 8. Then I would take this fraction and multiply it by the opposite fraction over itself. So that would mean I'd want to multiply this by 7 over 7. So I'm going to create 2 equivalent fractions here. 4 times 8 is 32. 8 times 7 is 56. 5 times 7 is 35. And 8 times 7 is 56. Now I'm hoping that you're noticing that when I multiplied each fraction by the opposite denominator over itself, I now have 2 fractions with the same denominator, which are easy to compare. More pieces are greater. So that would mean 5/8 is greater than 4/7. So let's try some. All 4 are up here. If you want to give them a shot on your own, go ahead. Otherwise, just follow along. Maybe after 1 or 2, you want to try the rest. You can always pause me. That's what's kind of nice about the video, right? It's hard to pause me during class. So I do not have the same numerator. I do not have the same denominator. I can't multiply 5 by something to get 8. So I'm going to multiply this fraction by that denominator over itself. And I'm going to multiply this fraction by that denominator over itself. So you're multiplying each by the opposite denominator over itself. That creates equivalent fractions. They're equivalent because a number over itself, that's equivalent to 1. 5 divided by 5 is 1. All right, so this fraction is now going to be 5 times 1 is 5, and 5 times 8 is 40. This fraction will be 8 times 2 is 16, 5 times 8, 40. Notice denominators are the same, right? So the higher numerator wins. 16/40 is greater than 5/40. Next, not the same numerator, not the same denominator. I can't multiply 3 by something to get 7. So I'm going to multiply this fraction by the opposite fraction's denominator over itself. And I'm going to multiply this fraction by the opposite fraction's denominator over itself. So this is now 15 over 21. And this is now 14 over 21. Pretty close, but 15 out of 21 is still greater than 14 out of 21 because those pieces are the same size. We're almost there. Okay, so I don't have the same numerator. I don't have the same denominator. I can't multiply 5 by something to get 6. So I will multiply this fraction by that denominator over itself. And I will multiply this fraction by that denominator over itself. So what I really have here is 25 over 30 being compared to 24 over 30. So same denominator, higher number of pieces wins. 5/6 is greater than 4/5. And last but not least, don't have the same numerator, don't have the same denominator. I can't multiply 8 by something to get 9, so I multiply this fraction by that opposite denominator over itself, and I will multiply this fraction by that fraction's denominator over itself. 9 times 6 is 54, 9 times 8 is 72. 7 times 8 is 56, 9 times 8 is 72. So now they're both out of the same amount. That means the pieces are the same size. What would be more? 56 of those pieces. You're all set. Good luck on your formative assessment.